Hi everyone, I'm CEO and founder of Mathficast Software Services Limited, the home of Butterfly AIs. Today, I'm going to use an example of uh, anomaly detection within ECG signals to explain the vision behind Mathficast and Butterfly AIs. I would also use another example as epileptic seizure detection using EEG brain signals to explain how this solution is problem agnostic. Now, this is a data for ECG anomalies uh, detection. Each row of this data is a time series showing like an ECG signal frame. The last column of this data represents the what we know as label, which is while we looking at this label, we can realize if the frame has anomaly or not. And label 1 indicates that we have an anomaly within this ECG signal. This data was labeled by human experts, medics, and those are the HCPs that are, by looking at analyzing this data, have scored as some problematic ECG with some anomalies. Now, the idea is to let Butterfly AI train itself and learn from this, and then to assist human HCPs and medical experts to uh, come up with a secondary decision in terms of detecting these anomalies. Now, when we detect these anomalies within ECG signals, we can identify the fact that there may be an underlying health problems with this specific patient. Now, in order to do start doing this prediction and detection of anomalies, I go to Butterfly AI software as a service platform. I have already logged in. I go to my dataset screen. Uh, the first stage is to clean and prepare data. I would name this data as say ECG version, I don't know, 9. And then what I'm going to do, I'm going to upload the ECG data that we have. In this case, we called it ECG anomaly. As soon as I save the data, the process of cleaning and preparing this data for training is going to start. Within this process, we are looking into removing the blanks, understanding the feature engineering, and also making a decision that which one of our super AI layers is the most suitable solution for this problem. Let's see if it's completed. It's done, already completed. We have now clean data, and all we need to do is to go to the training screen this time, use that clean data in order to perform training and learning and creating the models basically that would be used later to do further prediction and detection of anomalies. Let's go to the training screen. The scaling factor here is one of our parameters. It has been explained in our instruction manual on our website. And then we have this optimization threshold. We put it 0.8, 80%. This is the way of human telling AI when to stop the basically the training. So we want to give some control to human as like a human-centric AI. We want a human to have a say in the depth of optimization that AI is going to perform. The data set that we're going to be using is the same data set we cleaned right now, which is ECG version 9. And as I click the save, it's going to start the training process. So you can see that we are back on the training screen, and shortly we're going to see how it's progressing. It is progressing, and it's going to take a while in order to have complete results. Now, while this training is running, I would like to provide some overview of uh, main features of this Butterfly AI platform. We start by looking at how the things is done today if we want to do this sort of feature-based, label data-based prediction. Uh, how is it done today with today's AI, deep learning, and neural network? I have prepared these slides, and I'm going to present this process of current state of art. Let me see if I can get the slide that I'm looking for. Okay. So the way we have today is that the data scientist starts with creating what we know as a notebook uh, by performing some data exploration, understanding the data, normalizing the data, making to the format that they can consume the data, feature engineering, and then lots of experiments, model validation and evaluation, and comparison of different algorithmic solutions and ML solutions in order to come up with a model that is providing the best solution. The process can take 3 to 4 weeks, and what we know as, say, 3, 4 spikes. It's a costly process, and at the end, we just have like a raw model, and it's not the end of the process. We are just starting, as I'm going to explain. Then we need to prepare these models for production. We need to create runtime environment. If we want to take to scale, we need to have um, what we know as model risk evaluation, quality assurance, making sure that actually these models can be productionized, the security, and also risk mitigation. And when we are done, we need to move on to another stage, which is deploying for production. We need to create CI/CD pipelines, building these artifacts, and also we need to get into having some deployment strategies, build containers, and then scale this up and solve the problems scale. And finally, after we go live, we need to take care of these models in terms of monitoring their feedback, making sure that we don't have drift, and then also always keep an eye on this. So all this process together can take um, 3, 4 months or more in order to have something up and running in live at a scale. Where we have solved and we have built all these capabilities whenever it's required, and in doing that, we have just left the data labeling and preparation and feature engineering to data scientists. So Butterfly AI can avoid 80% of these costly processes. As you saw earlier, with just one click, I managed to clean the ECG data and have it ready for training. Now let's go back to our training screen and to see how we are progressing. It still is running. So what we have here is is an example of how we can see the logs, all the logs of the data, all the uh, what we have done so far in terms of training model, dataset ID. So we have a full visibility of the process. And now we can see that the process is completed. And we have this performance which is 96%. We know some of the best algorithms provide 94%. And we are confident that if we increase that threshold, we're going to go even higher in terms of performance. What is significant here is that in almost 2 clicks, we managed to get the models ready for basically to do the further training. Now, we can move on to prediction. Say in future we have number of unknown, unseen ECG frames that HCP and human experts, medical experts, they want to, and doctors, they want to see if they have anomaly or not, and they are not labeled. So all we need to do is to go to the prediction screen, and this time I'm going to create my prediction uh, batch prediction. Basically, we have a group of those predictions. I use the same data that we use for training, and then we get the best model for that data set. I'm going to upload the unseen ECG data, which is my blind ECG anomaly, and I'm going to open it. As soon as save, the prediction process is going to start. So we can see that progress is progressing. The unseen data, it was like a balanced data. So half of it has anomaly and half of it doesn't have anomaly. Let's see if we got the results. Uh, yes, we have the results. When you download this prediction results, you can actually see that we have what we get in terms of the results. Now, this is interesting. As you can see, this class shows if the results that if we have anomaly or not, and the probability indicates the certainty of our prediction, which is a very important parameter, how certain we are that it has anomaly or not. If you go to the half of data, immediately after half, you can see the ones appearing with some exceptions. And we managed to achieve almost 96% of accuracy with a blind detection of unseen ECG data, which is very significant in a couple of clicks. Now, uh, maybe here I provide further deeper insight into the capabilities that this Butterfly AI has. One of the major things that we have with Butterfly AIs is the fact that they can be seen as a predictive AI operating system, allowing data science teams to focus more on data quality, labeling, preparation, and other stages, leaving the primitives of what we know as training and prediction to the engine. This platform also allows multiple ways of integrating it basically with your existing workflow. From full software as a service, what web app that you can see right now in front of you on the screen, to REST API, to CLI app running in your desktop, and even uh, integrating into a Jupyter network. Butterfly AI is a low entry bar service to start building a predictive AI application. Uh, Already packaged with 20 plus known critical, most crucial problem spaces faced by world today within 20 plus business verticals, where actually they excel. Its flexibility makes it an all-in-one solution to quickly run training and prediction for prepared tabular data. Going from months of research and development time, as I explained, with, with today's AI, uh, to just few days and couple of clicks with Butterfly AI. That means that Butterfly AI, when it comes to this sort of medical diagnosis, reduces the time and cost to market mm, significantly. So both cost and time to market reduce significantly. Now, another very important feature of this Butterfly AIs is that it is a problem agnostic solution. That means that it's not customized for any specific medical prediction or medical classification or diagnosis problem. So let me explain this with a live forecast and prediction. Now we are going to look into a completely different problem. We are looking into detecting or predicting epileptic seizure within uh, basically using human EEG signals. In doing that, we are going to use this binary epileptic data. And this data is completely different from the data I used for ECG. As a matter of fact, this has been generated by applying discrete wavelet transform into EEG signals. So it's no longer time series, it's frequency. And the very important feature here is that your AI is no longer dealing with the time series, and we have, again, human expert uh, labeling this data, showing one if there is signs of future epileptic seizure, or we're detecting currently something or not. Now let's go back to Butterfly AI. With today's AI, you need to data scientists need to go back to the what we know as the notebook and start from scratch, creating new models, learning this new frequency-based data, how to normalize it, how to handle it. It's no longer a time series. And then building new models and comparing them and making sure that the new model is going to work for this epileptic seizure detection problem, which is different from ECG. Now, this is going to take another 3-4 weeks to handle this problem. And then follow up, you need to change your algorithm pipeline to accommodate this new models that the data scientist is going to create. So another maybe couple of months. So you can see that overall we have more costs and more time to handle a new problem. While opposite to that, and in contrast, Butterfly AI, all you need to do is just to add the new data, EEG, I call it version 10. I'm going to upload the data, which is the EEG, this time epileptic seizure data. And then let me just open it. As soon as I save it, again, the platform is going to start cleaning and learning from this data and feature engineering and understanding feature, extracting them, and also doing what we know as the best AI super layer for this. It's processing right now. Let's see if it's completed. It's going to take a while. Quite large data. Hopefully, we're going to have it completed now. The data, clean data is ready now. Now I'm going to straight to my training screen again. This time I'm going to create my training. I use a scaling factor of 100. We have done a couple of trials with these hyperparameters, and I put optimization threshold at 80%. And the data is the latest data, which is EEG version 10. Now, as I'm going to save the process of creating the new models for this problem is going to start. So click rather than weeks of work to get the models. Let's see how we're going to succeed with this, if we're going to succeed with this. So I'm now saving this, and I think this one is going to take a while also to complete. While this is going to complete, I'm going to provide some further insights into Butterfly AI. One of the key features of Butterfly AI is in line with current industry trend that we have is that it's a greener AI and environmentally friendly. Its learning training time far is far less than shorter than those of today's predictive AI, including neural network and deep learning. Minutes rather than hours, as you saw. It also saves tens of hours of data science research and engineering work, and as such consumes less energy. So it can be seen as future's more environmental friendly and greener AI. Butterfly AI doesn't use the traditional neuron layers or structure or architecture of that we find in neural networks and deep learnings of today. As such, it doesn't require an energy-hungry and expensive GPU to run. As a matter of fact, right now we are running Butterfly AI on a cheap 4-core CPU on a Google Cloud platform. Perhaps it's one of the cheapest CPUs that actually you can find today in ordinary laptop. While of course, if you do use GPU, you're going to get better and more uh, accurate results. Now, but at much less energy being consumed. The other very important key features of Butterfly AI is that they are fair and ethical AI. Most of today's predictive AI are usually biased towards larger classes, while missing small classes or anomalies. This may lead to significant problems, for example, failing to diagnose a cancer at very early stages. Butterfly AIs try its best to be a fair ethical AI because of employing some unique cellular balanced learning technology that we are extremely proud of. It makes AI happy because every class matters now to Butterfly AI. Even it's small, so it avoids bias towards large classes. And simultaneous optimization of, say, accuracy, precision, recall, and what we know as F1 score. Now, all of these together is an indication of having a superior solution and a, a disruptive solution that is leap forward in terms of taking artificial intelligence into new domain. But what we believe, strongly believe in also is human capability. Here, the idea is to enable medical experts to become super doctors, super HCPs. This is very important. This AI is not going to replace human. It is to give human extreme capabilities and turn them to superhuman. Now, I think this is running right now. We're going to see when it's going to end. Let me see if it's completed already. Okay, we have the results. So we have managed to achieve 92% accuracy of joint prediction of training data and test data. We explain this on the website what this metric is within our instruction manual. And this is significant because, as you saw, we avoided weeks of research on these models and spikes and all those work, all going and months of months to put this model into our pipeline production in order to tackle the problem, the new problem of um, epileptic seizure detection. Now, both problems of ECG and EEG based medical diagnosis have been handled so easily using this technology. Now, for prediction, again, I don't want to repeat this again. All you need to do is go to prediction, and you're going to this time create a new prediction. You're going to use the ECG, EEG data that we claimed and its associated model, and then you're going to this time upload my blind binary epileptic seizures data, which is unseen to platform. Again, it's a balanced data, and it has half of labeling, but this labeling is unknown to this model. Labeling has been removed. So let's see if we can save that, and then all we need to do when we save, we are going to see the hopefully to receive the prediction. Again, you can see, you can trace back all your activities within this platform, and you can have logs of all your activities, plus results and analysis of data. This is binary decision making. By the way, we have also multi-class decision making. For example, in ECG case, after you identify those problematic and you can see that this is completed now, problematic patients with anomaly within their heart signals, then if you have, say, label data, training label data for, say, 10 heart conditions as multiple classes, um, we can use the other capability that we have, which is complete automated, as a complementary to this ECG anomaly detection, to detect actually what exact heart condition that patient with anomaly within the heart signal is suffering from. Say we have 10 conditions, we would classify the patients that we detected they have this anomaly within the heart signal into 10 different diseases, as easy as we presented so far, and that's fully automated, multiple pipeline we have for multi-class classification. Thank you very much for your attention. I hope that you enjoyed this presentation. We're looking forward to hearing back from you. This is our website. Please feel free to visit our website at mathficast.co.uk, and you can see further details of our services and what we provide. Thank you.